In this video tutorial, we shall see programs on counters, and these programs have to be implemented using the subroutines. The first program is a 8-bit hexadecimal up counter. Let us first see the logic of this program. The logic is relatively very simple. So we have a 8-bit register. So we have to display the count on this 8-bit register, right? So the program is to implement a hexadecimal up counter, right? So we shall start the count from 00H, right? Then the next count is 01H, 02H, and this will continue. The maximum will be FFH, right? And after FFH, the count has to roll back. That is, it should start again from 00H. This is the program. And we shall display this count on any of the ports, right? Now, in this one thing which you should remember, and in fact this is applicable for most of the programs, right? So we human beings have some perception of I, right? To observe the difference, right? So if I send 00H to port 0, and immediately if I send the next count, I may not be able to differentiate between the counts. The reason is the clock the clock with which this code is working is in megahertz, right? It means to execute an instruction, it takes only microseconds, and we cannot differentiate if there is any change by microsecond. So what shall we do now? So after every count, we shall provide some suitable delay, right? So that we can notice the difference and we can see the change in the count, right? So the purpose of this delay is to only this, that because we cannot differentiate if it is working on megahertz, right? And this delay, you can provide some dummy delay, or you can also use some timers also. It is left to you, right? So in the lab, what we have done is we have given some dummy delay, wherein it's enough that we are able to see the difference in the count, right? So we shall write the program for the same. Now before this, we have to write this program using the subroutines, okay? So we shall write the subroutine for the delay program, okay? And subroutine should always be written after the forever loop and before the end directive, right? So this is the area where we write the subroutine, okay? Let's start the programming. Let's say I want to display the count on port 0. So I will make port 0 as output port. So P0 as output port, right? Now I will start displaying the count on port 0. So move P0 comma A, because I know that A by default A contains 00H, right? Afterwards I need to provide some delay, right? So that I can differentiate between the count. So for the next count, you can say add A comma hash 01, right? You can also write increment A, it doesn't matter, okay? And this has to be repeated forever, right? So sjump repeat. So the repeat will be here. So that's it, right? So you are sending the count to port 0, you are providing some delay, and afterwards you are incrementing so that you can display the next count, and this will be repeated forever, right? And because you already have forever loop, so this may not be required. Now I need to write a delay program. So I'm writing some dummy delay so that I can differentiate between the counts. So let's say move R0 comma hash 100. move r1 comma has 255, move r2 comma has 255, and I'm using two NOP instructions, right? First I will decrement the inner one, right? That is r2. You may use any register, r2 comma say loop 1. And the most important thing is, where do you place these loops? Okay, so here is where I place that loop, right? Then dj nset. The next is r1 comma l2. So my l2 will be here. Then at last dj nset r0 comma l3. So l3 will be here, right? And most importantly, in subroutines, don't forget to write the return instruction, right? So this is one of the common mistakes students do, right? So let us build this program and let us debug this, right? So to view the output, go to IO ports and click on port 0, right? Now, how do you execute this program? Until now, we have executed all these programs using the step execution. But here, it will take a lot of time because you have a delay, and every time you have to display the count. For that, you just click on the run button, right? So once you run, the count will be displayed, right? 4, 5, 6, right? And if you want to see it much faster, you can stop this. It is just to check out whether all the counts are getting displayed or not. I will simply decrease it to 10, and still I can notice the difference. Okay, so I will run this. Now I can see this. See that it counts until FF, and also there is a rollover, right? After FF, it should display 00. It's displaying in hexadecimal. So I can say after FF, it has displayed 00. Okay, so that's all about this program.